Welcome back, guys. In the previous video, we drew the diagram for this question. In this video, we are going to go ahead and solve the second part of our question, which is finding the bearing of z from x. How do we find the bearing of z from x? As we saw in the previous video, in order to find the bearing of z from x, we have to connect x to z as we've done here. Then we will draw our little x and y plane on x because that is our starting point. We are finding the bearing of z from x. So we have to draw the x and y plane on x. Okay, so the bearing of z from x will be measured from, if you remember our 3-point bearing, we say that we measure from the geographic north, which is this side here, in the clockwise direction. So it will be measured from this line straight up to the line connecting x to z. So our bearing of z from x will be measured from this point onto the line connecting x to z. But we know that from this point here to this point here is 180 degrees. So the only thing we really need to find is this angle here. If we're able to find that angle and add it to 180 degrees, we can now find the bearing of z from x. So all our work is going to be towards finding this angle here, so that we can add it to 180 degrees in order to get the bearing of z from x. Now let's start. We know that this triangle XYZ is an isosceles triangle, because isosceles triangle has two of its sides being equal. So triangle XYZ is isosceles because YX and YZ are the same. We also know that if this side here is 70 degrees, then this side here will be 20 degrees because here is 0 degrees and here is 90 degrees. So if here is 70 degrees, then this side here will be 20 degrees. So we can say that from the diagram, angle XYZ, which is this angle, is 80 degrees. 20 degrees plus 60 degrees will give us 80 degrees. If you watch the video on Introduction to Plane Geometry, I explained how to name angle there, so you understand why this angle is called angle XYZ. So we have this to be 80 degrees. As we said previously, triangle XYZ is an isosceles triangle. So angle YZX and angle YXZ are the same. So if here is n, here is also going to be n. If you want to understand why angle YXZ is equal to angle why angle YZX is equal to angle YXZ, it has been explained in the video on angle properties of triangles. If you watch that video, you will understand the properties of isosceles triangles, and you will see that the angle created here and the angle created here are the same. So if I call this one angle n, this one is also going to be angle n. From the properties of triangles, we know that the sum of the interior angles of a triangle is equal to 180 degrees. So if we add everything in this triangle XYZ, we are going to get 180 degrees. So n plus 80 degrees will give us 180 degrees. If you simplify this, you will see that n will give us 50 degrees. So we have been able to find one of the angles here, 50 degrees. Let's move on. Our main interest is finding this angle here. Our main interest is in finding this small angle here so that we can add it to 180 degrees to get the bearing of z from x. We have been able to find here this angle here to be 50 degrees. Now look at something. If we extend this line, I'm going to do that again. I'm going to clean it and do it again. If we extend this line, and we extend this line. I hope you get the picture. So we extend this line and we extend this line. You will see that these two lines here are parallel lines. So this line here, this is what I mean. This line here and this line here are parallel lines. And if they are parallel lines, then line YX becomes the transversal. If line YX is the transversal, the angle created here, which is 20 degrees, and the angle that will be formed here will be alternating angles. We know from plane geometry that alternating angles are equal. Once again, I explained this property of alternating angles in the angle properties of parallel lines. So if you watch that video too, you will get more knowledge about alternating angles. So because alternating angles are equal, if here is 20 degrees, this side here is also going to be 20 degrees. Now look at something. We have been able to find this side here to be 20 degrees. We have been able to find this side here to be 50 degrees. We know that from this point to this point, the total angles here is 90 degrees. From this point here, which is the 270 degrees point, to this point here, which is the 180 degrees point, the angles between them, between 270 degrees and 180 degrees, the angle there is 90 degrees. We are found here to be 20 degrees, here to be 50 degrees. So what is left will be for this space here, and that will give us 20 degrees, because 90 degrees minus 20 degrees minus 50 degrees will give us 20 degrees. So if you add all this, you see that the total angle there will be 90 degrees. So we have been able to find this angle here, which is 20 degrees. That was what we were looking for. We said that as soon as we get that angle, to find the bearing of Z from X, it is going to be this. From this side here, up onto the line connecting X to Z. And we have been able to find this angle here to be 20 degrees. We know that from the zero line to this side here is 180 degrees. So we just add 180 degrees to 20 degrees. So we can say that from the diagram, the bearing of Z from X is 180 degrees plus 20 degrees. And what is 180 degrees plus 20 degrees? We are going to get 200 degrees. So we can say that from this diagram, the bearing of Z from X is 200 degrees. Thank you so much for watching this video. Don't forget to like and subscribe. In the next video, we are going to solve another question of this nature. Bye bye.